Welcome back. Okay, so examiners report that section 2.3, types of interactions in protein structure, is literally one of the most misunderstood areas in Cambridge biology. So let's fix that right now in this explainer. If you're aiming for those top-tier marks, you already know that simply memorizing the textbook just isn't going to cut it anymore. Today, we're conducting a complete exam autopsy to show you exactly what the examiners are desperately looking for and why so many students completely miss the mark. Let's get into it. All right, take a look at this comparison right here. We're exposing the exact painful mistake that candidates make within the first few seconds of their exam, a mistake that instantly costs them a top grade. You see a standard descriptive answer about hydrogen bonds holding a protein together. Looks okay, right? Well, wrong. Why does it get 0 marks? Because it is way too generic. It completely fails to connect the structural interactions to the specific biological function, or even to the data provided in the question. And honestly, that is the cold hard truth of high-level biology exams. Moving into Section 1, Core Protein Structure Theory, and exactly why ordinary revision fails you here. Listen, simply memorizing textbook facts is a recipe for disaster. You could know every single bond, disulfide, ionic, hydrogen, hydrophobic interactions, the whole shebang. But if you just list them off like a grocery list, you're gonna lose points. The crucial takeaway is that this assessment framework prioritizes precise cause and effect relationships over just, superficial breadth. Examiners really want to see that you understand the why. Like, how does a change in temperature or pH disrupt specific ionic or hydrogen bonds? How does that alter the tertiary 3D structure? And how does that ultimately denature the active site? It's all about building a chain of analytical depth. Now, this right here is a real game changer. Examiners are actively hunting for cross-topic connections. If you can reference specific statistical tests alongside these protein structure concepts, you will achieve significantly higher marks. Think about it. If an exam question asks you to analyze the reaction rates of an enzyme, which of course is a protein, at different temperatures, don't just ramble on about kinetic energy and bonds. Look at the data. Are you comparing two means? Then you've got to mention a t-test. Are you looking at a relationship between two continuous variables? Drop a mention of a correlation test. This is exactly how you prove to the examiner that you're actually thinking like a practicing scientist, not just a robot. But hold on a second, because in just a few minutes, I'm going to reveal a hidden clue that examiners actually leave in the prompt, a clue that shifts absolutely everything. But first, we need to build the procedural framework to make that clue completely obvious to you. Because if you don't understand how the exam is actively structured to test your methodology, well, that hidden clue is just going to fly right over your head. Which brings us perfectly to Section 2, the technical methodology, and how to secure the method mark strategy. By following a really clear step-by-step procedure like the one you see here, you completely avoid term overload. Plus, you secure crucial method marks just for your process, even if your final calculation ends up being totally wrong. I want you to look closely at Step 4, identify anomalies. Seriously, so many students just skip right from making an observation straight to the conclusion. Don't do that. If you just take a brief moment to state, hey, data point X appears anomalous because, boom, you've just secured a method mark. Examiners are assessing your experimental logic here. They want to see you select the correct apparatus, systematically follow the instructions, and carefully record data way before you ever attempt to draw a conclusion. So, how do top-scoring candidates actually demonstrate this evaluative thinking? The golden rule here is simple. Show you're working. And guys, this does not just apply to math. In biology, showing you're working means explicitly quoting the data straight from the provided graphs. Don't just give a lazy answer like, the rate increased. No, you need to say the rate increased from X to Y as the temperature reached optimum, disrupting specific hydrogen bonds. You've got to extract the data, run the statistics, and let that hard evidence drive your conclusion. Now we're entering the danger zone. Section 3, top examiner warnings straight from the principal examiner reports. Check out this number, just 3. 3 fatal traps are responsible for the vast majority of dropped grades in this entire topic. So let's uncover exactly what they are right now, so you never fall into them. Literally, examiners are begging you to be specific, to use the correct units, and to anchor your protein interactions to the actual scenario given in the prompt. Let's break it down. Trap number 1, being way too vague. Don't just write bonds. You need to specify hydrophobic interactions in the core of the globular protein. Huge difference, right? Trap number 2, messing up units and terminology. If the graph is in millimoles, you better write millimoles. And trap number 3, ignoring the context entirely. If the question is about hemoglobin, your answer absolutely must relate the structure specifically to oxygen binding, not just some general protein theory you memorized. Look at this quote directly from the examiners. When they ask you to evaluate, these higher order objectives mean you absolutely cannot just write a simple summary. You have to identify limitations and alternative interpretations. You're shifting your answer from just being descriptive to being highly analytical. You need to be able to look at an experimental design and say, well, okay, the conclusion assumes temperature remained constant, but the lack of a water bath is a clear limitation. It's exactly that level of critical analysis that unlocks the top mark bands for sure. All right, let's put it all together in Section 4, the top band answer and applying the framework. So here's what success actually looks like. This improved top band answer directly implements all the specific terminology, methodology, and cross-topic references we've been talking about. Notice how it doesn't just lazily describe the structure. Instead, it identifies the specific R-group interactions. It pulls a highly specific data point straight from the prompt, links the disruption of ionic bonds to a pH shift, and even mentions that a chi-squared test would be appropriate for the categorical data presented. Honestly, it's just a masterpiece of precision. If you lock this specific 4-step narrative structure into your mind, I promise you'll naturally trigger the mark scheme requirements for literally any protein interaction question. It's like a cheat code. Start with step 1, identify the biological concept, like tertiary structure, for example. Step 2, pull the exact evidence or data from the prompt to back it up. Step 3, apply your scientific reasoning to explain the actual mechanism, like how thermal energy breaks very specific bonds. And finally, step 4, you seal the deal using exact examiner wording, tossing in phrases like denaturation of the active site or enzyme substrate complexes can no longer form. Okay, remember that hidden examiner clue I promised you earlier? Well, here it is. And this is the ultimate provocative question I want to leave you with. What if your biological framework is absolutely perfect, but a single hidden command word in the prompt reduces your grade to a fat 0? Because all this perfect biological structure we just learned means absolutely nothing if you misinterpret the one word that dictates the entire mark scheme. If you provide a brilliant 4-step explanation when the command word only asked you to describe, you are getting 0 marks for that brilliant explanation. The command word is literally the master key to everything. So to solve this massive vulnerability once and for all, make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to completely excel in your Cambridge examinations. And then I want you to immediately click into our next explainer where we decode the exact command words that basically decide your final mark band. You've mastered the biology today, so now let's master the exam language. I'll see you right over there in the next explainer.